There's an experiment that proves reality literally changes when you look at it. Not metaphorically, not theoretically, actually changes. The double slit experiment has been called the most important experiment in physics history. And after you understand it, you'll never see the universe the same way again. This isn't some fringe theory. This has been verified in labs thousands of times since 1927. As of July 2026, quantum computers are using these exact principles. By the end of this video, you'll understand why Nobel Prize winning physicists have lost sleep over this. Why some scientists think consciousness might be fundamental to reality itself. Let's start with something simple. A wave in water. When it hits a barrier with two slits, it creates an interference pattern. Waves overlapping, creating bright and dark bands. Now imagine shooting tiny particles like electrons at a wall with two slits. You'd expect two bands on the detector behind it, right? Like throwing baseballs through two holes. But that's not what happens. Instead, you get an interference pattern. Multiple bands. Like the particles are behaving as waves, going through both slits simultaneously. Wait, you might think. Maybe the particles are bouncing off each other, creating the pattern. So scientists shot them one at a time. One single electron every few seconds. The interference pattern still appeared. Over time, dot by dot, it built up, meaning each individual particle somehow interfered with itself. It went through both slits at once. A single particle, existing in multiple locations simultaneously. This is called superposition, and it's not science fiction. It's measured reality. Think about that for a second. An electron isn't in one place or the other. It's in both. It exists as a probability wave until something forces it to choose. But here's where it gets absolutely insane. Scientists decided to measure which slit each particle actually went through. They put detectors at the slits to watch. The moment they added detectors, the interference pattern disappeared. Completely. The particles started behaving like particles again. Two bands. Like nothing weird ever happened. Let me repeat that because it's crucial. The act of observation changed the outcome. When measured, particles act like particles. When not measured, they act like waves. This isn't about disturbing the particles with clunky equipment. Modern experiments in 2026 use incredibly sophisticated detection that doesn't physically touch anything. It's about information. If the universe has information about which path was taken, wave behavior stops. If that information doesn't exist, wave behavior continues. Scientists even did delayed choice experiments. They decided whether to measure after the particle already went through the slits. It still worked backwards. The future measurement affected past behavior. Now we're not just breaking physics, we're breaking time itself, or at least our understanding of cause and effect. Quantum eraser experiments took this even further. They measured which slit, then erased that information. The interference pattern came back. Like reality was rewritten. Think about what this means. The universe doesn't just exist in one definite state. It exists in all possible states until forced to commit to one. And what forces it to commit? Observation, measurement, interaction with the macroscopic world, the boundary between quantum weirdness and everyday reality. This is called wave function collapse. The particle's wave of possibilities collapses into one definite outcome the moment it's observed. But what counts as an observer? Does it need to be conscious? A human? Or can a machine do it? This question has sparked decades of debate. Most physicists today agree consciousness isn't required. Any interaction that creates a permanent record counts. But some scientists aren't convinced. The physicist John Wheeler proposed the participatory universe. The idea that observers aren't just watching reality, they're helping to create it. Without observation, the universe exists only as probabilities. Reality crystallizes into definite form through the act of measurement. This isn't philosophy anymore. It's experimental fact. The quantum world genuinely doesn't follow the rules we experience in everyday life. Einstein hated this. He famously said God doesn't play dice with the universe. He spent years trying to prove quantum mechanics was incomplete. He proposed hidden variables. Maybe there's information we can't see that determines everything in advance. Particles just seem random because we're missing data. But in the 1960s, John Bell developed a theorem that could test this. And every experiment since has proven Einstein wrong. There are no hidden variables. So what's really happening? Nobody knows for certain. There are interpretations. The Copenhagen interpretation says particles exist in superposition until measured. The many-world interpretation says every possibility actually happens. The universe splits into parallel versions for every quantum outcome. That means there's a universe where you didn't click this video. Another where quantum mechanics was never discovered. Infinite branches, all equally real. The pilot wave theory suggests particles do have definite positions, but they're guided by a real physical wave we can't directly observe. None of these interpretations change the math. They all predict the same experimental results. We can't prove which one is correct because they're observationally identical. What we do know is that quantum mechanics is the most precisely tested theory in all of science. Every prediction has been verified to incredible precision. Your smartphone works because of quantum mechanics. GPS satellites account for quantum effects. Medical imaging relies on it. This is an abstract philosophy. As of 2026, quantum computers are starting to solve problems classical computers never could. They use superposition to process multiple calculations simultaneously. The double-slit experiment isn't just a curiosity. It's the foundation of technologies that are reshaping our world right now. But more than that, it challenges everything we think we know about reality. It suggests the universe is far stranger than our everyday experience prepares us for. The physicist Niels Bohr said, "If quantum mechanics hasn't profoundly shocked you, you haven't understood it yet." And he was absolutely right. We live in a universe where particles can be in two places at once, where observation affects reality, where the future can influence the past. And the wildest part? This isn't speculation. This is what the experiments show us. Reality itself is far more mysterious than we ever imagined. The double-slit experiment proves that at the deepest level, the universe doesn't work the way our intuition tells us it should. And that's beautiful. If this blew your mind, smash that like button and subscribe to your Space Wizard. We're exploring the wildest mysteries of the universe every single week. The universe is stranger and more wonderful than we ever dreamed. And understanding that strangeness is what makes us truly alive to reality.